Okay, so let's work on example 3.11 from the OpenStax textbook. Let's first read the problem. Suppose a car merges into the freeway on a 200-meter long ramp. If its initial velocity is 10 meters per second and it accelerates at 2 meters per second squared, how long does it take the car to travel 200 meters up the ramp? And it then just adds this information might be useful to a traffic engineer, which is very true. So okay, in general, we're going to follow the same problem-solving strategy that we've used in the past. We're going to first draw a picture and define a coordinate system. All right, so I'm going to define my x equals 0, and I'm going to define my plus x direction. Okay, so this is x equals 0, and this is my plus x direction. So I've drawn a nice picture. I have a car which is initially at x equals 0. It's going to end up at some final position. X final is equal to 200 meters. And it's good for me to use a nice notation, so I'm going to label my initial position x sub 0 to mean my position at time equals 0. Okay. Let's now read the problem a little bit more carefully and write down, make sure we have all our knowns and unknowns. So we do know that the ramp is 200 meters long. Right, so I've written down x final is equal to 200 meters. This also means that one of our other knowns is that delta x is equal to 200 meters. Right, our displacement is equal to 200 meters. They also tell us that our initial velocity is 10 meters per second, so I can write that down as v naught, our velocity at time equals 0, is equal to 10 meters per second. Right, so I have, this car that's located here at time equals 0, at the x equals 0, and initially has some velocity of 10 meters per second in the plus x direction. Okay. What other knowns do they give us? They tell us that it has acceleration of 2 meters per second squared. Right? And that looks like it's a constant, right? It doesn't change throughout this. So that's another important piece of information, that the acceleration throughout this process, acceleration is equal to 2.00 meters per second squared. Right? So as this car moves, it has a constant acceleration at all moments in time. Right, so it's going to be moving faster and faster and faster as it moves down the ramp. Okay, and now let's look at the question one more time and figure out what are they trying to get us to answer. What is the unknown here? The unknown is identified as how long does it take the car to travel up the ramp. So we want to know the time it takes to go from x equals 0 to x final equals 200 meters. Right, so the unknown here is the time. Right, how much time elapsed from time equals 0 to the time it gets to x equals 200 meters. Okay, so we've set up the problem, we've drawn a nice picture, we're all ready to actually start solving the problem now. And so we need to figure out what is the major conceptual physics concept here in this problem, and then figure out which equation is relevant. Okay, so the major concept is again identified right here for us. Right, the acceleration in this problem is a constant. Right, and we know that if you have constant acceleration, then we can use these 4 special kinematic equations that only apply when you have constant acceleration. So in any problem, when you identify this constant acceleration, it's a good idea to just write down those 4 problems. Maybe they'll be helpful or relevant to you later on when you're solving the problem. Okay, so of those 4 equations, we need to now look at our knowns and unknowns and identify which equation is most relevant. Meaning we want to identify the equation that has one unknown and everything else is known. Okay, so based on my interpretation here, the equation I think would be most useful is this one. X is equal to x naught plus v naught t plus 1/2 at squared. Right, I could label this x final to more match what we've defined already. Right, so we can look at this equation and check what are our knowns and unknowns. We know our final position is 200 meters. We know our initial position is 0 meters. We know our initial velocity is 10 meters per second. We know our acceleration is 2 meters per second squared. Right, so this equation only has one unknown, and that is time. Right, time is our unknown, and that's what we want to solve for here. Okay, so let's plug in. Our final position is 200 meters. Our initial position is 0, plus v naught is 10 meters per second, times time plus 1/2 2.00 meters per second squared t squared. Okay, this looks a little bit tricky. How am I going to solve for time? Well, let's rearrange it a little bit. I'll move the 200 to the other side of this equation and just write this in a slightly different way. I have 0 is equal to, and this term I have 1/2 times 2, so that just gives me 1 meters per second squared t squared plus 10 meters per second t plus, oops, let me just say minus 200. Alright, so that's what we have now, and we have to solve this problem. Alright, so this is one of these times where we have to bring some of our mathematical knowledge into solving the problem and recognize that this is a formula, a quadratic formula, and we're going to have to use a quadratic formula to solve it. Right? Typically we would call whatever constant is in front of the t squared, whatever is squared, right? Whatever is here we would call a, whatever is in front of the t we would call b, and whatever is not in front of any variable we call c. Right? And then we write down the quadratic formula. That is, t here is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's how we're going to solve this. I can now plug in. So t is equal to, my constant b is equal to 10, so this is negative 10 plus or minus the square root of 10 squared minus 4 times a, which is 1, times c, which is minus 200, all over 2 times a, which is 1. Okay, so it's a little bit messy, but you can plug this into your calculator both with this plus sign and this minus sign, and we get t is equal to 10 seconds, or t is equal to minus 20 seconds. Right, so we get two different answers, but we can identify one of them makes conceptual sense and one doesn't. Right? You can't travel from one side of a ramp to another in negative time, so we're definitely going to choose the positive answer here and say this is our final answer. The time is equal to 10 seconds. Okay, so it's very similar to the other constant acceleration problems we've done, except this time we just, in order to solve it mathematically, we need to bring in the quadratic formula. Okay, so let me know if you have any questions on those.